All right, so as your notes for today, we're not going to cover any new material in the book, but I am going to explain problems 9 and 10 from yesterday's assignment. Then we're going to go over example 3 on page 40. And before that, I want to talk to you about estimating angle measures. Okay. When you are estimating angle measures, you kind of want to be able to take a coordinate plane and picture it laying over your angle. Or we'll start with a coordinate plane, because anytime that a vertical line intersects a horizontal line, creates a 90-degree angle, right? So this angle right here is automatically 90 degrees. Now, if I take another ray and I put my pencil on the origin and I go up and to the right at a slope of 1, but basically I just bisect this 90-degree angle. And if I bisect this 90-degree angle, I go right through the upper right corner of this red box. Now, if this initial angle in quadrant 1 of the coordinate plane was 90 degrees and I just bisected it, what degree angle measure is the new angle?
45.
So this is a 45-degree angle, isn't it?
Yeah.
And if I extend it the other direction, no, I'm creating another 45-degree angle down here, right? Now, if I were to split those in half, aren't they just going to be half of 45 each? So now we're down to 22-degree angles. On the left-hand side in quadrant 2 here, this angle is also 90 degrees. But if I kind of estimate thirds of this angle, and I take a ray out here a third of the way, and then another third of the way, wouldn't each of these new angles in quadrant 2 be 30 degrees? So just by using the coordinate plane, dividing quadrant 1 in half, we get two 45-degree angles. Taking quadrant 2 and dividing it by 3, we get 3 30-degree angles. Down here on the bottom in quadrant 4, we've got another 90-degree angle. So if I highlight this angle right here, I'm going to call it, for right now, I'm just going to call it the yellow angle. If our angle measure in quadrant 4 is 90 degrees, and this piece in quadrant 3 is 45 degrees, then wouldn't the yellow angle be equal to 90 plus 45? If we needed this angle measure right here, that yellow angle, it would be 90 plus 45. And 90 plus 45 is 100. and 35 degrees. So do you see how using the coordinate plane, you can estimate angle measures? All right. So next, let's look at problems 9 and 10 in the book from yesterday. That's page 41. And the best advice that I can give you on problems like that are to always draw a diagram. So the first thing you do is you read the facts that are given in the figure. KJ and KL are opposite rays. So if KJ and KL are opposite rays, they form a straight line. So this part right here, point K is right here. Here's L, and here's J. KJ and KL are opposite rays. Opposite rays form a line, and a line measures 180 degrees. KN bisects LKM. K to N bisects LKM. So let's draw LK. Here's LKM. KN bisects it. So we're going to put a ray right here that bisects this angle. And this is point N. We said yesterday that an angle bisector splits an angle into two congruent angles. So these two angles become equal to each other. Everybody with me so far? Now, if you look at number 9, the information given says if the measure of LKM. So here's LKM. We start at L, we go to K, and then we go up to M. We're looking at this yellow angle right here. That's our reference. If the measure of LKM is 7x minus 5. So what I like to do is put that measure on there, meaning this entire yellow angle measures 7x minus 5. The whole yellow angle. And the measure of NKM, N down to K to M, one of the smaller congruent angles, it measures 3x plus 9. Here's what you need. You need the measure of angle, LKM. That's the yellow angle. Well, this expression represents that angle, but that expression's got a variable in it. So in order to find that angle measure, we need to know what that variable is equal to. So now back to this big picture. If MKN is 3x plus 9, what's the measure of NKL? 3x plus 9, because the angles are congruent. Congruent angles have the same measure. So now we've got a 3x plus 9 plus a 3x plus 9 that has to equal 7x minus 5. So we write an equation. A 3x plus 9 plus 3x plus 9 is equal to 7x minus 5. Now, the next thing we need to do is combine our like terms. So a 3x plus a 3x is a 6x. A 9 plus a 9 is 18, and that's equal to 7x minus 5. So we're still solving for x. You're going to subtract 6x from each side. 18 equals x minus 5. And then add 5 to each side. So 23 is equal to x. That wasn't quite the question, though. That was only part of the question. The question was find the measure of angle LKM. Well, if LKM was equal to 7x minus 5, then the measure of LKM is equal to 7 times x, which is 23, minus 5. $156. The two smaller angles that form a larger angle, or if two smaller angles form a larger angle, then the sum of their measures is equal to the measure of the big angle. You'd be better off just watching for a second and not writing. If I draw an angle here, angle ABC, and then I bisect it, and this is 30 degrees and this is 30 degrees, what's the measure of angle ABC? Isn't it 60? The 30 plus 30? Okay. Now watch, don't write. You're better off just watching for a second. If I give you this, angle ABC, and I put a ray in here, and I tell you that the measure of ABC is equal to 75 degrees, and the measure of ABD is 40 degrees. What is the measure of angle DBC? Isn't it 75 minus 40? Which is 35 degrees. So the two smaller angles that form the big angle, their sum is the measure of the big angle. So the bigger angle minus one of the smaller angles equals the other smaller angle. It's like the segment addition rule that we did in week 1. Okay? So let's look at number 10 from yesterday's assignment. Same picture. So I'm going to draw that same picture. Well, yeah, I'm going to draw the same picture. We've got JKL again. Got KM right here. And KN. Now we're going to get a little bit different information. If the measure of NKL is right here. We start at N, we go to K, and we go to L. If the measure of NKL is 7x minus 9, and the measure of JKM from J to K to M is x plus 3. Find the measure of JKN. All right, we need JKN. We need the measure of angle JKN. Now, the original information still holds true. KN, Here's K to N. It bisects LKM. So these two are still congruent. So if those two angles are still congruent, what is the measure of MKN? 7x minus 9. Now, in our notes yesterday, we said that opposite rays form a straight line. And what's the angle measure of a straight line? 180. So that means that all of these angles up top, these three angles that we have expressions for, they all sum 180 degrees. So some of you can add the x to the 7x to the 7x, but I'm just going to write it all out. We're going to take x plus 3 plus 7x minus 9 plus another 7x minus 9. And those three angles added together have to equal 180. So now we combine the x, the 7x, and the 7x, and we get 15x. I got a positive 3, a negative 9, and another negative 9. Negative 15 equals 180. Add 15 to each side. We get a 15x that's equal to 195. Divide both sides by 15. And our x is equal to 13. But we need the measure of JKN. So the measure of JKN is going to be this x plus 3 plus the 7x minus 9, right? So our JKN is going to be equal to 13 plus 3 plus 7 times 13 minus 9. So our 13 plus 3 is 16. And then our 7 times 13 is 91 minus 9 is 82. So the measure of our JKN, 98 degrees. So does that help a little bit from yesterday? The key is, to me, drawing a diagram, getting the data into the diagram, using your highlighters to mark up what you're actually looking for, set up your equation, solve for x, and then substitute. All right, so here's what I'd like you to do today. Your practice is going to be on page 42. Problems 37 through 42. Again, please check the odds in the back of the book as you're completing the problems. And if you're struggling, come see me and I will be glad to help you.